Hello, everyone, and welcome to yet another webinar session organized by Factana Computing. We really appreciate and thank everyone present for taking the time and joining us in this webinar session. My name is Prasad, and I'm Customer Success Manager at Factana. A quick brief on today's topic, which is AI transformation in industrial operations. For those who have been part of our previous webinar, we are glad to have you back. But for those who are joining us for the first time, I would like to take a moment to provide a brief introduction to Factana Computing and the services we offer. So, Factana Computing is a leading provider of solutions or applications for Industry 4.0. We have been assisting numerous small, medium, and large enterprises in their journey toward adopting Industry 4.0 and digitizing their manufacturing operations. With a global presence, Factana operates in India, Europe, and the United States of America. Mr. Hariharan Ganesh, who is the founder and chief architect of Factana Computing, will be presenting this webinar. Before getting started, a quick note to all, if you have any questions, do not hesitate to ask. You can ask your question in the chat box, which will be answered toward the end of the webinar in the Q&A session. A recorded session of this webinar will be uploaded soon on our YouTube channel. And for those who will be watching the recorded session of this webinar, you can post your queries in the comment section on our YouTube channel. We'll be happy to answer them all. So without further delay, let me quickly hand over to Hari. Over to you, Hari.
Okay. Thank you, everyone. Thanks for joining this webinar session. So today we are going to talk about how to kick off the AI. This is the most common question that being asked in the industry. Everyone is curious about the AI trend happening now. Industrialists are also curious, and but at the same time, there are a lot of questions around, whether it's really relevant to them or not, how to approach this, and where to start. Are they ready for this, transformation or AI adoption within the operation side? And whether they are fully ready, and what should they do to make them ready for the AI, adopting the new AI technologies into the day-to-day operation side. So, so the objective is to create awareness on how to launch AI program and successfully transform into industrial operations. It's not about just a technology; it's about how people are adopting the technology, using the tools, and leveraging the capability provided by the advanced AI that are available today. The AI is getting mature day by day, so there are a lot of progress is happening. Every industry sector is trying to leverage these new capabilities to advance their in innovation and operation side of that. So 5 key areas that we are going to target in today's session. Well, understanding the market, market study, and what industries talks about and where it's going into. Also talk about how the landscape of the industrial sector, especially manufacturing, and why AI is important, or how AI is going to add a value to them, or how AI is going to solve the day-to-day problems today. And where do we start it, right? Because the whole core of this session is all about how to start it, where to start it, and what should I do. And in that way, starting with assessment is the foundation. So we are going to present a framework that we follow as part of our exercise, to help our customers to study whether they are fully ready for AI, or where do they start with. And then building a strategy and having a vision, and how do we go about this, from the state of idea to all the way to the realization. And then one of the success case study that we would like to share here, and how we have helped using our tools and technologies that we already built for manufacturing industry and digital operation side of that. So we'll go one by one. Let's start with the market study, because we need to have some kind of because there are a lot of hype is happening here. So let's look at what is really industry talks about. From from adapting AI into the manufacturing space or industrial operation space. So McKinsey's survey back in 2024, recommends or states that 72% of manufacturers are interested in adapting AI, but also have a questions on how to approach it. Not sure how to approach it, but there are interest on that, to leverage AI, because everywhere they are hearing AI is, doing big things in every industry. So manufacturing execution team also, leadership team also interested to learn about this and leverage this. Um, at this, and also, to support that and how much the value will be. World Economic Forum published a article and the survey results that indicates more than $4 trillion global value will be there. When you say value, it's not just about the AI projects and implementation. It's about the value driven by the AI to the manufacturing industries. So up to $4 trillion values could be arrived out of this innovation and AI wave happening today. And the early manufacturers or industry operators, adapting these technologies will help them to enhance their revenue channels and optimizing their current operating model and take them to the more competitive, scale on that. So these are two things, but at the same time, there is a challenge like AI. Also, there are a lot of initiatives taken in the past. Not everybody is successful. Not everybody truly seeing the value fully into that. The many AI projects are in the pilot phase itself. It's not into the full scale because of the various challenges that companies are going through. And we are going to talk about that, how do we mitigate such as challenges when we're taking the AI initiatives. But why are we talking about AI now? What is it is going to make a change here, right? So first, let us look at the challenges, the most top five challenges that industry goes through, and then how what is the impact of that, and then we will look at how the AI will solve the problem. The topmost industry, almost 62% of surveys suggesting that industry leaders are concerned about labor shortage, blue collar worker shortage, and the knowledge, because in the manufacturing industry is hundreds of years old, but at least 35 years, it has been a primary industry sector in global scale. And many of them are, the many of the workforce are initially started with the company and being there around 20-25 years. Now they are moving into retirement state. That means that the new generations are coming into the factory floors and start working on that. But at the same time, the knowledge that the people are retiring, gained, it's going to be a shortage to continue on the operation side of that. So that's the biggest challenge. How do we retain the knowledge? People are retiring. How do we bring that knowledge to the new generations, to transition to the new generation, so that the manufacturer can continue to optimize their activities and processes, things and all. So that's the biggest challenge. So labor shortage and the knowledge availability is the biggest shortage, and that's going to impact heavily on the manufacturing in the next 5 to 10 years. So that's the biggest challenge that we have to solve it. The second most challenge is the rising cost of operating cost, especially energy cost. Energy cost, when the global uh, industries are moving into more battery operated model, EV models, but of course manufacturers also moving into more into sustainable energy model. But at the same time, the cost of operating is continue to scale up even after, especially after pandemic. More than 27% of the energy cost has raised, which actually adding more and more burden to the manufacturing operations, because the over cost is basically cutting down the profitability, and that's result in need of more cost effective operational model. One of the key area that we look at is how do we move from the existing energy usage to the newer model, efficient systems, efficient energy, sustainable energy, and how do we use that grids in properly and things like that. So that's the biggest challenge. So that's need more technology solution as well as more optimization, energy optimization practices. The third most thing is on this supply chain, especially in the current market conditions. Global tariff and other global challenges, which creates more challenges for climate condition also, creating more challenges for the shipping and supply chain. And that's it adding to 72% of elevated cost in fuel, labor, logistic expenses, shipping thing, delays and things like that. Again, supply demands are also forcing to burn the cost of labor cost, and then obviously the production will be down, which result in a financial loss for the industrial sector. So that's creating another bigger challenge for manufacturers to identify and solve, operate more efficiently, to plan ahead and then execute things. But how do we plan ahead, and based on what, right? So that's what the solution that we are looking at today. The fourth one is all about the downtime. It is a ongoing one, being there more than 50 years. But as the technology mature, we are moving into more and more advanced technology. So the downtime, prediction and prevention is significantly reducing. But the company should move from the traditional maintenance operations to the more predictable maintenance operations to cut the cost and use the parts efficiently, and then run the operations more effectively with the less downtime, which also helps to save across $50 billion annually for the global manufacturing sector. The last one is on the regulations and the new regulations and climate change enforcement and monetary things and all. So that's required significant investment from the CFO standpoint to put cost into the energy savings, or ESG standpoint, to how do we create how do we manage the compliance side of that. But the challenge in the compliance side, traditionally the compliances and reports that the regulatory demands are manually entered data sets, which required somebody to go and manually measure, monitor, and then entering the data manually, and then creating some reports. That report has to go through, and that adds a significant workload and cost of investment manually doing things that could also be automated or improved with the help of the new AI technologies available in the market. So that's another significant area where more than 32% of CFOs are interested to understand how to regularize their ESG compliances and reporting practice, to run operate more cost effective way on that. So end of the day, cost is the biggest challenge, and in the production efficiency is the second most biggest challenge. Both of them has to be, the cost has to be reduced, the efficiency has to be increased. So which basically result in, to for the better optimized operating model and continue to grow on that. So let's take a look at one by one and look at what are the different AI technology available to solve that challenges. So let's start with the labor shortage, right? The labor shortage is, as we have seen, it's more of a knowledge gap. How do we retain the knowledge? How do we, help the new generation workforce to, start, getting that knowledge that being gained over the years? Because somebody managing their assets for 20, 25 years exactly knew, when there is some problem, and the new people, new workforce may not have that much knowledge to pinpoint the problem and go and fix it quickly. So they need time to analyze and then come up with a solution for the any production issues or machinery issues. So for that, and also the workforce, right? The workforce, manual workforce, assembling team on machine operators who operates manually, and also their skill set are also getting shortage on that. So moving into more mechanical based automation to the robotic automation is the significant way, and the industries are moving, especially intelligence driven, not just a pre-programmed robotics, but a more of intelligence driven robotic model. So that gives more comfort to make the robot making decisions on situational, and then taking controls on the production processes. So that's a major technology advancement to moving into industry 5.0, where fully autonomous operating model. So AI powered robotics, not just a pre-programmed robotics, AI powered robotics are adding more value to the assembly line, reducing significant workforce dependency, and also intelligently acting based on the situational environmental conditions. The second one is in terms of the operational team, as mission operators, as well as the maintenance team need assistance because new people are coming into the board and they are started managing the production floor operations, and they need assistance, right? So always the previous generation or experienced experts in the factory floors are getting retired. How do we transfer knowledge? How much we document it? It's not going to help. But they need instant access to the data, instant assistance. When you look at the problem, they need a quick access center. So that's where generative AI or AI based solutions are nowadays accessibility is very easier, more more easy to interact with, more human language understandable technology, so that the maintenance and operating teams can start using that assistance to scan and get the advices and then work on that. So this helps, and also the knowledge gained from the previous generation operators to transition to the new generation with the help of GenAI, so that the knowledge retained at the system level rather than in the human brain. So this is one of the biggest advantage of reducing the dependency with the workforce. At the same time, empowering the workforce, newer workforce, to start using this technology. The safety side of that, right? Traditional safety side of there are quality inspections, using things done with the help of manually somebody seeing it, right? So instead of that, computer vision based AI models that helps to identify the safety issues faster enough, or identifying the quality issues faster enough before human eyes or human can detect that, and then track that information and then enhance their that helps to enhance the safety and compliance related metrics. Also, training people with simulation is possible with the help of AI, because, newcomers are coming. How do we transfer the knowledge to them, right? So give them the tools so that they can go and simulate it, self-test test, and then, then before they go to the day-to-day production operations. So this also helps. So there are a set of AI tools that helps, and this creates a big impact in the market, especially, by adapting this technology, advanced technology, increase the productivity as per the market study and projections. It's in between 15% to 25% increase the productivity, reduce the troubleshooting time, especially newcomers to the machine operations, and they may not aware of exact pinpoint like experienced experts. So they need assistance. So the assistance helps them to reduce the time for them to troubleshoot the issue with up to 50%, and safety measurements are increased to 40%. So reduction of incidents will result in better safety and secure environment, and obviously compliance with the ESG requirements. So altogether, so technology adds, the certain type of AI technologies applying to the different scale at the different roles helps to reduce the the demand and dependency with the workforce shortages. Now, next one is rising energy costs, right? So energy costs, of course, monitoring and optimizing the energy usage. But how do we monitor and optimize the energy usage? That's how we can reduce the cost. There is no other option, right? So because the tariff is the rate card and tariff is increasing. At the same time, we need to reduce efficiently. We need to operate it. So there are a combination of technologies. IoT, obviously, the data collection part of that is from the IoT side, and then machine learning, AI-based machine learning models helps to predict the energy usage on a peak time and non-peak times and things like that. And then adjusting and recommending to adjust the production operation or switching the type of energy controls, like from these grid level supply to the solar supply energy, or solar supply energy to the grid level, depends on the usage pattern. Depends on the consumption pattern, identifying that and then giving the suggestion recommendation to switch it, and it could be automatically switching as well with the help of automation in future. Second thing is, in terms of energy usage helps on the maintenance aspect of that. In terms of machinery usage, how much energy consumption in the past versus today, and how much is difference between that. And based on that, we can do the predictive maintenance, because the more energy consumption, that indicates that the particular machine or motor or pump is degrading from its performance. That means it's consuming more energy cost. So by doing a maintenance operations, that we could reduce that energy wastage on that. It's basically called energy wastage. So doing appropriate maintenance operations will help us to reduce the energy cost on that. Um, Based on the grid usage and cost factors, how do we plan and execute the production itself, right? So the planning and execution of production based on the usage of the energy and cost factors will help us to planning certain production schedule and production line behavior schedules accordingly. So AI driven predictable production scheduling helps to optimize the production timing based on the energy consumptions aspect of that. And then the last one is switching between the systems, energy systems, based on the usage and the cost factors. Example, high extreme good weather condition, especially hot conditions, more solar energy produce could be used for certain equipment productions. In a cloudy day, we can move into grid because of the energy production may not be that efficient from the solar system. So switching into the grid system based on the climate conditions helps to continue to operate at the same time. Switching between the grid or supplies energy source helps to reduce the cost as well. So energy level, we can apply different technology, AI technologies, to apply different to gain different values out of that, and that results in 80 to 15% of overall operating expenses reduced by saving the cost on the energy. And then carbon emission also reduced, which also helps to compliance with the ESG and environmental compliances aspect of that. Third one is on the supply chain, right? So supply chain, again, we have seen that, there is an increased cost in the fuel cost, labor cost, and logistic expenses, especially when you say logistics, essential supply and delays and things related to that. And that also directly impact the production schedule as well. So in that case, using a demand forecasting, machine learning based demand, AI powered machine learning based demand forecasting help to identify, what is our production, what is the demand in the market, what is the production happening, what is the stock availability in the raw material availability, or distribution availability into the different warehouses. How do we automate this process? How do we predict this and then automate this process? How do we make sure that the right timing of material ordering and stocking helps us to move the materials to different multi-plant locations. How do we move the things together? So the demand forecasting helps that, and obviously AI play a major role on that to automatically apply the algorithms to come up with the recommendations. Reducing the supply risk based on the suppliers efficiency, the road conditions, climate conditions, situational anomalies, sudden incidents. Based on that, how do we move the shipping routing and things like that, can be adjusted based on the risk analysis part of that. By again using ML based risk analysis model to identify that the routing risk, and accordingly rerouting it to the right direction to make sure the shipment is happening on the right timing. So which is also we can apply a ML based risk analysis models. Then inventory management in terms of where was movement, shipping the raw material versus finished goods. How do we move to different distribution locations based on the market demand, based on the customer inquiries, based on the orders? How do we move that together? Is again AI ML based model to inventory management aspect of that. The last one is on the routing, generative AI and maps to use combined together to identify the best routing and give a recommendation to the shipping executives, so that they need not spend time to analyze the data. Instead of that, they get a recommendation directly to prompting them to work on it. So again, giving in a human understandable format with the help of generative AI at the same time using ML to detect that best routing model, and the combination of that will give the better interaction responsiveness to the supply chain executives. So again, the use of these technologies help us to improve the forecasting by 30 to 50%, which is significant value or from the supply chain standpoint, and automating the part supplies 10 to 20%, and warehouse movement and things like that. So there are huge value that could be arrived at the as a adoption of these newer advanced technologies into the day-to-day operations, especially in supply chain. Now, downtime, we have seen, we discussed this before also, but again, machine monitoring, machine productivity, and then machine efficiency, cost optimization, all are part of the asset management. So in the asset management aspect of that, how do we predict the, asset conditions, which basically using IoT and AI combination, especially IoT and ML models to identify the predictant, and then, when the system is about to degrade, and then do the maintenance activity at the right time rather than on schedule based maintenance activity, which also increase labor cost, part cost, and operational cost. Because when you do the maintenance operation, obviously the system has to be down. That directly result in production downtime, right? So doing the right time, the right maintenance is also helps to increase the productivity, at the same time reduce the cost as well. It's a double shot on that. So that means we need to have a prediction model, which is the most advanced one, and most of the companies started adapting the predictive maintenance. Anomaly detection helps to detect the ML based anomaly detection help to detect the machine conditions and degradations, so that we can plan the maintenance operations quickly. The new advanced computer visions helps to identify the issues even before. Like some of the machineries may not be sensor ready. We may not able to fit the sensor into that to sense the conditions of that, the environmental conditions of that. So using a computer camera visions to identify the machine operating conditions, kind of like a fog conditions of the machine operating, or the smoke conditions, or fire conditions, and that things and all, or the rising temperature on the belt, or any other condition, color changes, based on the color condition, color changes, we could identify that issues with the help of camera devices to start streaming the cam videos, and then doing video intelligence, or the image intelligence based models. The last one is the demand forecasting. Avoid parts demand forecasting, similar to the supply forecasting, but parts demand forecasting based on the maintenance needs and things like that. How do we get that on time? These kind of technologies help us to save significant cost in the asset operations management, and in that case, up to 30 to 50% on the predictions, based on the predictive maintenance based downtime reductions, and main maintenance system degradation and preventions, and also part cost. So there is a 10 to 50% of cost savings, or efficiency improvement possible with the help of these technologies. The last one is the ESG or regulatory requirements. Um, as we have looked at that, the data collection is the biggest challenge in the ESG standpoint, because we're going and doing some measurement manually to identify and then collecting the incidents again manually, and feeding all the data as a data entry work to the ESG systems, and trying to create a report, supporting materials from the machineries, maintenance metrics, and things like that. Everything it needs to be consolidated together, right? So for that, you can help of IoT to get the mission condition, mission operating or environmental conditions, and then safety measures. Apply with energy, and create a summary report using generative AI or energy or whatever it is. I think the generative AI or LLM is more advanced in this case. And then start using a computer vision for visual image capturings, and then putting that as part of the evidences collections to consolidate together as reports, creating automatically with the help of generative AI, and presenting to the compliances or the governance boards, helps to reduce the operating cost in the manual effort. At the same time, creating more accurate information, data capturing information, and then presenting it to that will helps to reduce the cost and being compliant with the regulatory needs. Again, generative AI being used, ML can be used for data analytics, and computer vision can be used for evidence collection, things like that. So if you put all of them together, right? So there are many different AI tools, or the technology or framework, whatever way you call it, that is applicable to different use cases, different things. So now we have seen as a consolidate together, we have seen that ML is models are required for predictive analytics and machine maintenance. Anomaly detection is used for machine condition monitoring. Computer visions are used for visual inspections. Even either machinery maintenance aspect of that or the safety aspect of that. Deep learning for robotic automation, especially reducing the workforce dependency and manual effort. Generative AI being used for instructions, knowledge transfer, maintenance recommendations and things like that. Again, generative AI and LLMs are used for workflow automation, agent-based workflow automations. Some of the automation process, like taking the data and creating summary report for the ESG, and using generative AI for that report generation with a human readable content generation that can be presented to the board and things like that. So all of them are, possible, but there is something as a core, right? So the core is the data. So now to apply this technology, we need to have solid data sets. And the data sets could be collected from the different way from the different systems using IoT, manual data entries. IT systems are giving some data entries. Third-party systems like environmental conditions, environmental third-party suppliers data, traffic conditions, all of them can give us the information about the routing model, and map data will give that. So all of this data coming from the different sources are required for us to build the efficient system in that. So the foundation for any AI solution is the data, and data has to be in the right place at the right time, with the right quality. To create these efficient solutions and deploy into that. So the core of this is the data. Now the topic, right? So the how do we kickstart? Okay, we understand that there is a problem statement, there is a solutions available, there are different solutions are available. But how do we go about this, right? So where do we start it? What is how I can solve these challenges and how I can move into that? Because according to Gartner's report, more than 50% of the AI projects are failing or not moving beyond the pilot phase stage itself. And the reason is unclear business objective. Means, yeah, they are hearing from people saying AI, oh, I want to do something in the AI, I want to bring AI to my operations. Suddenly, having some smaller scope, going and looking at that, okay, I want to have some predictive maintenance. Okay, so you get this solution from vendor or you build yourself, doesn't matter. You have a predictive maintenance system in place. But what is the result of that? How do you measure it? And if you solve one problem, do you think, it will be solving the entire operational challenges? No, you basically touching only 10 to 20% of the effort on that. So what is the action after the prediction, right? So let's take predictive maintenance itself. There is a system in place and giving a fantastic dashboard where I can see that when is the next maintenance, but who is going to act on it? How we can carry the data to the process side of that? How do we ensure that the process followed so that the issues are solved before happens? If only prediction happening but action is not happening, that also result in the same thing, because there is no use of AI into that, because there is no action out of that. Only prediction happen on that. So the major challenge for AI projects are not the technology challenges, but in the approach and then the objective of that. So having just a smaller scope and going after that is not going to solve the total challenges. Instead of that, we need to look at that as a comprehensive way of approach. And the purpose of transformation itself, the moving towards AI, is to reduce the automate the things, processes seamlessly, and then reduce the data, labor workforce dependency, increase efficiency, reduce cost. So all of them needs in the different level of scale of approach, right? So moving from anonymous operating model to autonomous operation model, which we called as a transformation. Again, AI play a major role on the autonomous. So that need a incremental or visionary approach from what you are seeing to where we need to go. So having a first clear business objective or vision is very critical on identifying where and how we are going to apply AI, and how these are solving the comprehensive problem, not just one problem alone. or one simple step into that. So first, having a clear vision and idea is the first one. And management support is critical on the vision side to move towards the matured AI transformation. Otherwise, the results may not be accurate as predicted in the market study. Second most step is the having a proper data sets. So very, very crucial. Without the proper data sets, it's not possible to implement a efficient AI system that could lead into autonomous solution in the future. So moving, data foundation is the critical. We are going to see that today. Um, the infrastructure, right? So having a right infrastructure capability is critical because data is there, but having to deploy the AI models and things like that, having a proper infrastructure is in place. We will talk about that. And then the process is, how do we identify the process? Which process are impact because of the AI adoption? How do we bring the AI as part of the existing operating processes? How do we bring that to that? Example, operator having a solution on hand. How do they access the AI, right? So how do they access it? How do they interact with the AI? And what basis they are going to interact with it? How do they apply their manual process with the AI with the help of digital tools, right? The combination of digital and physical, right? So these two things are combined together is where we need to look at how do we apply that, and then bringing that into the process of holistic automation. That's what is resulting into the autonomous stage. Moving towards autonomous should be the goal, vision, and steps towards that is where you need to carefully look at that. And for that, we created a readiness. Are we ready for this, right? So first step itself, we talked about vision and data. Are we ready with the data? Are we ready with the processes? Are we ready with the operational, where we need to apply that? So we need to identify these conditions before we start the any major AI transformation or AI transformation itself, or even simple AI initiative itself, because you need to have a vision first, clearly. So to do that, we created a framework called AI readiness assessment. So it's exclusively for the industrial cases, especially for manufacturing and asset intensive operating environments. So we start with the data. So as the vision is there, right? We start with the data. So first fundamental thing is the data has to be clear. So we identify the data availability, accessibility from the operating systems, from the IT systems, and third-party systems. Example, you may have a CCTV cameras which already have a record of videos. You may need a computer vision cameras to do certain camera detections and all, or you may need the third-party information from third-party sources like environmental conditions or climate conditions or other things, right? So all of them we need to collect it together. So that's just data, accessibility, and availability. So we go through the process of identifying whether, by looking at your current operating system or system that you already have in the OT side, IT side, to understand how do we extract this data together, or are the data available in a system like a SCADA or cloud systems. So we study the data accessibility availability standpoint, especially from the IT OT sectors aspect of that. Then we move into and identify the gaps in that, so that we know that where we are lagging in the data and how do we mitigate that. That's the number one step. Number two step is to identify the infrastructure. Okay, once we have that way of identifying the gap and fulfillment, then are we ready to run this AI models? Are we ready to are we capable of running the AI model? What is the current OT network? Because the data has to come in real time, right? So OT network, when I talk about OT, it's a wireless network or wired network. How do we collect the data from the machineries? How do we transition to the to the central data repository? How do you process it, right? Where do we process it centralized? So all of them we need to think about that. So OT network assessment, which is again part of the infrastructure, and then IT infrastructure in terms of cloud architecture or any technology tools and technology, how the application systems are being there. We understand that, we study that, we assess that. We identify the data storage capacity available and where that data can be persisted and processed. Then we identify what kind of AI tools already exist in place and what kind of new tools are required. as per the workflows and visions. We identify that from the infrastructure standpoint, and we estimating with what additional infrastructure capabilities required before we go into that and the cost associated with that. Third stage is on the operational side. Okay, we understand data, we understand infrastructure. Now we're going moving into operational side. In the operational side, very important to understand the current operating production process or operational side, the factory floor operations. How people or operators are interacting with the machines. What kind of way they are manually doing things. How are they exchanging communications? How are they how the parts are moving things? How the finished goods are moving things, so we understand physically how you are operating in the shop floor level and collecting those production processes that already followed. Like, you may have a production sheet, you may have a maintenance sheet, you may have different data logger sheet or logging sheets. So we collect all these data sets and we understand, your workforce maturity because people has to adapt the technology, right? So it's not just about tools and technology. It's also people should adapt it. So understanding, interacting with the workforce to understand their maturity level, their tech usage level, their knowledge in technology, especially new generations are more they have more knowledgeable in the technology than the experienced workforce. How do we get them on board into the new tool adoptions like a co-pilot? If you're giving a chatbot to them, they should know that how to use it, right? So that means we need to understand their internal skill sets and capabilities. So assessing that and then understanding that the process and the tech capabilities or gaps, people use gaps and knowledge enhancement or the training requirements based on the operational conditions. We collect that. And the fourth one is with the business leaders. So now interacting with the business leader to understand what they're really looking at from the operational standpoint, what they are looking at, what is the output they are expecting, how the leaderships are ready to enforce this technology or tools to the operational side of that. Are they bought out to go for AI, or is there any conflict between the business leaders? And then how do we educate them to bring them on board to roll out these solutions at the scale so that the results are at the scale, right? The ROIs are at the scale. So how do we get their blessings to move forward and do things efficiently? So that's a fourth one. Again, it's a part of the process. Understand the people leadership knowledge, experience, and how they are applying it and technology adoptions and things like that. Also part of that, business goal, visions, and all. We understand that. By combining all of them, we come up with the key performance indicators, KPIs, on the each level, the data readiness level, infrastructure level, operational and business. And then, come up with the identifying gaps, fulfilling gaps, steps required to move forward on the roadmap. And that's how, we move into that. And of course, all these stages, we follow the governance as part of that, is the foundation because policies and compliances are most critical foundation layer in terms of the data policy, data compliances, infrastructure side of that, security, operational side of compliances like requirements, safety, and things like that. All of them we collected. So from the compliance is one of the angle that we put together in all over the layer and collect all the details. And using that, we give the recommendation results. And this assessments gives the 360-degree view of the organization readiness, especially operational readiness, if we implement AI-based tools and technologies in practice. But understanding, having a solid knowledge on the data, because we are talking more importance in the data, because the success of AI adoption is not on, not just, going and buying a software or the tool from the cloud, but also, in how do we how do we feed the data to that? How do we, get the output from it? Because the system is just an engine that runs, but it required a fuel, and the data is the fuel for the AI systems. And the fuel has to be clean enough to give a proper output. Otherwise, the AI system may not give any results to that. So having a AI to go into AI and data is the foundation. So we created a model that helps to understand how we should set together. So of course, the data collection part using different technologies, IoT or any other tools and integration tools and things like that. We use it to collect the OT, IT data, and then third-party data. These data are fed into the centralized repository, which we call it as a data lake, where all the data are stored, like in like the lake where all the water molecules are stored. So similarly, we store all the data into the lake. From the lake, we build the different engineering models, merging, cleaning, and data engineering models, especially to make sure that the accuracy of the data is important for the AI. So we need to have that proper, because when we collect the data, there will be a lot of data could come in a different scale. So we need to collect that. So we collect together. We put together a engineering model where we merge the data, clean the data, enrich the data, annotate the video data, and then meta mark the data, abstracting like data, and then storing all these process together. Once the cleansed qualified data are in place, then that data will be used by the AI engineering tools. Again, different AI, when I say AI engineering, it's combination of different ML models and computer vision models, generative LLM models, different models are there, right? So we need to apply different models for different use cases. And obviously, we should have that catalog in place, the model catalog in place, so that we can apply different models in different cases. We need to build the analytics so that they using AI we can build the predictive analytics and then our predictive metrics, predictive maintenance, predictive KPIs, or foreseeing some of the safety issues, and then predicting the supply chain needs. So all of them are predictive analytics, and then creating a predictive analytics data sets that can be fed into the system, and then the computer vision for detecting from the visual images and videos, chatbot to embed this in the application systems or the operating systems. So OT or IT systems. So every operators and in the operating system side, operational sides, operating users are adapting it. IT side, the system users are adapting the chatbot based interfaces so that they can interact with the AI tools efficiently, and then automating this process with the help of agents to workflow automation, things like that. So these are the 5 different components or modules we require within the AI landscape, so that we can address different cases. You could start with one area and move on to other things, but at the same time, addressing the case by case. But also, you should have that vision and then the foundation knowledge to go after that, because you cannot go, just solving one problem, one use case without having a solid foundation layer. So the data lake is for unifying the data. The data engineering is for enriching the data, making the data accuracy, integrity, maintaining the integrity, and then AI engineering is to enhancing the data with the help of intelligence and preparing the data to present to the different use cases. The use cases we identified predictive maintenance, quality metrics, and safety measurement, workforce assistance with the help of knowledge management, workflow automation, the automation resulting in the better robotic solution deployment, and also into the autonomous practice into the manufacturing operation side. So that's the foundation layer put together on how we move forward into that. Now, okay, so now we understand that there is a assessment. The end of assessment, we are coming up with some kind of a roadmap strategy. But also we understand that we need to have a clear data foundation. So the combination of what we are going to do and what approach we need to take it up based on the current gap. So the future landscape is in the data foundation and the AI foundation. The assessment gives that where we are standing, right? The assessment gives the current situation so that we understand that future, we need to go to the future, but we are standing right now here. And this is how we are going to move forward. And that's what the roadmap is all about, right? So from the roadmap standpoint, how do we move forward, right? So we understand that from the assessment, we understand the gaps. Now let's look at that, what is the business objective? That's the result of the assessment itself. So because the end of the assessment, you will know that what is your business objective, business cases that you want to solve it, and what is your data level of capabilities, right? So from that, using that, you identify the business objective. Step is one is business objective, and then identify the business cases where AI can be applied. You may go phase by phase, like you may go for simply a predictive maintenance first, and then you can go to the next, maybe visual inspection, and you may go into quality checks, you may go into operator enforcement, or ESG. It depends on what your organization challenges, which is highest priority for you. You can go on the use case by use case. But objective and use cases should be identified first. Then train the model. Model is ready, or the foundation layer, concept is ready, but we need to deploy it, right? So we need to create a data pipelines. So build a data pipelines and deploy it. So you collect the data, number one. Number two is qualifying the data and staging it, as we have seen that, data lake, data processing, right? So data engineering. So the second stage is data engineering, do cleaning and cleansing, and then identifying the data sets, metadata, prepare a, if in this case you are using AI, prepare a, generative AI, use a RAG to identify that contextual copilot, implementation standpoint. And then, deploy the models on the third stage. That we are going to the next level. So AI engineering side of that, where, based on the data, once the data is processed, we identify the data, and then we started, train the data with the help of models, and the model being trained, and deploy the models. Either you are deploying at the cloud level or edge level, depends on, use cases. If it is a computer vision, you could deploy it in the edge level. If it is a, predictions, you could do it in the cloud level. Predictive metrics, you can do it in the cloud level. Depends on, where you want to deploy the models. So you can, deploy the models. Once you deploy the models, then model is ready for usage. Then how do we embed that into the existing workflows? When I say workflows, operational flows, as well as in the application systems or systems. Example, the IT systems we could embed with as part of that Copilot, or embedded within that as embedded metrics and things like that. Whereas in operating systems, like may provide a tablet app to the operators, or embed within your PLC systems or your robotic systems, existing robot systems, to automate certain processes. So embedding AI output to, or the model, trained model with your existing system is a critical step to take this effort to the hands of the operators, so they can start interacting with as part of the day-to-day cycle, rather than completely a new tool to them. It should not be a new tool. If you don't have anything, then you could introduce a new tool or technology. But if you already have a system in place, and you need to see how you can embed this within the system to seamlessly adapting the technology. Now, but is that something we are going to do big bang? No, we are going to do in a phase by phase. So as I said, we'll go in the pilot phases first. We'll roll out to the pilot phase, and then step one. But the foundation should be ready for you. So you may even collect the data from only machine data and do the predictions, and then roll out the predictive maintenance as a step one. But you also should look at the same path that you have gone through should be ready for subsequent data feeding as well. So as you move forward from the pilot to the next of the phase, you need to have the same channel to feed into that. That's the foundation layer. So having a pilot ready, and then going into the human loop, get the feedback, improve the systems as we go. Monitor and govern the AI process itself is an important step on that. So this is the step by step you need to go, and you can go in a continuous improvement of operations. And this is how you need to approach it after you identify where you are today through assessment, and where you want to go, which is a model, foundation model. And then, then your roadmap will be clear on that. Okay, so what we have done, just to give a case study on how we have applied this. Of course, we have gone through this in the past. We studied this in the past, and then we have prepared our own solutions in this space aspect of that. So one of our customer, quick win on this, because it's building is one side or buying is the second step, right? So we have option of both. We can build for the customer, or customer wants to buy a quick solution, but at the same time having a longer vision and AI roadmap. They could also use our AI powered smart manufacturing platform. We call it as the following. So either one of them could go with that. This customer has gone with our existing platform. So the challenge is, the customer has 3 plant, 1,200 employees. They are more automotive engine blocks and valve manufacturers for the larger manufacturing companies in India. And they use CNC machineries, heat treatment machineries, grinding machineries, CNC grinding machineries to create the components for the parts. And they were running in operating in a OE metric 62 percentage, which is significantly low. They initially thought if they are in very high, OE 85 percentage. After we, redefined that calculations, it arrived at 62 percentage. 18 hours and more of unplanned downtime per month. And then the first pass yield is 94.2 percentage, which was significant. It was lower, so they wanted to improve from there where they are to that. So the key things here is improve the productivity, improve the reduce the downtime, and then create a better quality output. Right, three major areas. So they want to cut down the downtime. So obviously, that requires a predictive maintenance, and then the process of maintenance operations. Second one is they want to have a quality output, right? So the quality output should be measured more accurately. So having a computer vision based quality inspection helps to identify the issues much faster, easier, and then giving instructions to the team. Um, Safety also is one of the concerns. So the safety measurement also we have done it with the help of PPE monitoring for operators to use the right tools while drilling and grinding and things like that. And then the maintenance team or the operations team need a AI assistance so that they can be instructed here, even the quality teams to understand it. So we embedded this as part of the systems that we provide. So we provide a co-pilot, so that co-pilot is embedded part of the system to give the instructions. So altogether, we deploy our smart manufacturing platform, which gives all these three. It gives multiple areas, but we have deployed these fogging CMS for predictive maintenance, fogging vision for quality. These two are work together. And then fogging eco is for environmental and PPE detection. Again, computer vision based PPE monitoring tool model that we deployed on the edge to identify that identify any PPE compliance issues. And then embedded the co-pilot as part of these solutions helps them to start applying this quickly, but at the same time the foundation that we provided as part of our platform, so they can start using this more efficiently. So that resulted in no more 52% of reduction in their downtime. So from 18 hours to 9 to 8 hours is what reduced so far, and we still working on to improve further. And then they have increased their quality by 5% from 95 to 99%, 94 to 99%. And then the safety compliance has increased by 70%. So that's a result of that quick win for them at this using the technology. But at the same time, the vision is clear. How do we roll out? And whatever we talked about, right? We started the assessment, we did the assessment, we created the foundation, what they really need. And then, we apply the tools softwares that we already built into those use cases to give the quick win results for the customer. Okay, so what we offer as part of our services, we have a foundation layer, advanced, and then the edge layer. So foundations are more basic analytics, machine learning models. Advanced, we put our conversational AI co-pilot, agentic AI, those kind of things we put together as advanced AI models that we offer. And then the edge level, computer visions, prediction on the edge, on agentic AI on the edge, all of them we offer it as part of our services. So depends on the customers, whether they want to build or buy, depends on the use cases, depends on their needs, and depends on the assessment results. We do provide the adequate technology solutions to our customers. We also have an open-ended free to use AI Copilot, which is in app mode, so you can download and start using it. So AI Copilot helps in the operational team to improve that, and they have questions related to operational issues. They have problems that they are not sure how to solve it. They can go and ask questions, and it's responded. It's more of chat-based options, and it can give the instructions, comments, and then how they can increase their knowledge. So the knowledge management is already built with that, so it gives all the industrial best practices to the operating teams. With that, we end up the session, and I hand over back to Prasad. Prasad, over to you.
Thank you, Mr. Hariharan, for the deep insight. We have a few questions. I'll be reading them one by one, and then you can respond to them. So the first question here is, what is the return on investment from AI, and how do we measure it?
Okay, so this is a very, very common question being asked whenever we go any AI-based solutions to customers. This is the most common question the leadership ask. What is the ROI? So we need to be clear on this. This itself is a one webinar topic. Probably, we should conduct one webinar on the ROI side itself because there are a lot of misunderstanding in this area. ROI is considered into two different levels. So one is the direct ROI, indirect ROI. What is direct ROI? Direct ROIs are, when you're investing time and effort on technology side, immediately you are seeing certain kind of a direct cost savings, which suppose yeah parts usage reduced. That's a direct cost savings because as a result of that process, you are able to save the part usage. You're reducing the part usage. Your maintenance is efficiently happening, your part usage is coming, your supplies are on demand, you are not having a overhead cost related to operating manually, you have reduced time in the maintenance, you have reduced downtime. So these are all direct cost result of that. But indirect cost or indirect ROIR, basically, sorry, indirect ROIR basically a result of this efficiency. So one is you save the cost, that's the ROI, that's direct ROI. And then indirect ROI is because of the efficiency improvement. What is the business result of that? How much you increase your productivity? How many new orders you are able to handle it? How much efficiently you are able to deliver it with the same labor, same operating time, same procedures, but you are able to do more productivity and delivering more quality of products to your customers, resulting in a better business. That's indirect ROI. We basically collect the data from the customers. We cannot say, one customer there is no one number for every applicable to everybody. Oh, if you do AI implementation, let's take predictive maintenance implementation, you will be saying saving 200% ROI. No, it's not like that. So it's based on your current baseline. Like, you see the case study, right? So we have defined what is the current OEE downtime, what is the current baseline value. We should have the data first. Many of them may not even have the data. So we should have the data. So we collect it as part of our assessment, and then we collecting it, and then we give based on that standard. We set the baseline. From the baseline post implementation, we identify what is the value that's coming out of that expected value, and then we can arrive the ROI. So from the baseline to the efficiency, what is the difference between that is the resulting in the ROI. So we calculate it, and it is case by case basis. It is not like a standard calculation that we can use it as a number. So we do that as part of our assessment itself to support it. And that's why we offer assessment. Of course, we offer free assessment for industrial operations because we have a clean framework, we have a clean template. So we could make it in a 2 weeks period, even it's a smaller scale or larger scale, depends on the size. We could do that, but we have a free assessment offer. So anyone who would like to leverage our assessment, you can contact us and we can do it for you. Yes, yeah, Prasad, go ahead.
Okay. So the second question is, how do we handle the organization change that comes with the AI adoption?
So that's part of the knowledge development, training, and processes. So we again we learned from the past that just deploying technology is not going to help. The people have to adapt it. That's why two way we are saying it. One is embedding this as part of the day-to-day practice. That's number one. Whatever technology we are bringing, like AI technology or AI-based recommendations engines, that should be part of the day-to-day systems. So it should be part of their journey, day-to-day journey. At the same time, how to leverage that is we need to train them, right? So it's two flavor on that to make the adoption successful. One is embedding it to the process, and then second one is training them to use the technology. Both has to happen, and continuous improvement of training should happen. As part of our customer success, we do a lot of training process, right? So we handhold them day to day, to give them more instructions and to elevate them to use the technology clearly. So training play a major role on this.
Okay. So the third question is, how do we manage the risk and ensure security when implementing AI?
That's again part of our assessment, when we do the infrastructure assessment section. So we do that security risk assessment as part of that to understand what is the current security protocols followed, and then how these technologies are going to fit together in the infrastructure, and what are the different technical security to be applied on that to ensure that that we are not misguided by any any security breach or security challenges, or even the compliance standpoint, know how do we use the data accurately, right? And how do we secure the data properly? So that is part of our assessment. And again, it's case by case based on the infrastructure. The security assessment will be done, and then recommendation will be created, and that will be part of the roadmap itself. So to as part of the rollout, before we roll out, we need to make sure the infrastructure is ready, right? So that the infrastructure side, we will set up the foundation security layer and then go from there.
Okay, okay. That was all the question that we had. Thank you, Hari, for answering all the questions. I hope it was helpful for all who have asked and other as well. Now I think it's time to wind up the webinar. As previously stated, we will be uploading the recorded version of this webinar to our YouTube channel. Therefore, you can also visit our YouTube channel to watch this or any other past webinar session that we had earlier. And for those who are interested in gaining further insight into IoT Industry 4.0 or smart factories, we encourage you to explore our blog section at www.fogwind.io /blog. Additionally, if you are seeking collaboration opportunities, please don't hesitate to contact us at sales@factana.com. Thank you once again for everyone for participating in this session and contributing to its success. We eagerly anticipate connecting with you in the next webinar. Stay tuned and have a wonderful day. Bye bye.
Thank you, everyone.